So Mr. Satya will be doing reactivity series, concepts and questions. I'll show you the kind of questions which are made in reactivity series. Yeah. So you'll have questions like these. Three metals XYZ were reacted with water. The oxides of the three metals were also heated strongly with carbon. So this is the table which tells you how XYZ behaved with the water and how their metal oxides behaved with carbon. Mr. Satya, is it making any sense or not?
Yes, sir.
See, it won't make any sense now, but we'll spend some time to understand what is reactivity series. Have we understood the behavior of sodium with the water, Satya?
Yes, sir.
So we are pretty comfortable. We know how sodium reacts with water, and this is the series. Have we crammed the series or not?
Yes, sir.
See, unless and until we cram the series, we won't be able to go forward. Any doubt about the series?
No, sir.
So what we have understood? Yes, Satya.
Sir, is there lithium in this? Like, because my friends.
Yeah. So when you Google reactivity series, you'll get all kind of results. So more or less there'll be few elements missing here or there. Have you understood?
Okay, sir.
So for example, this is the series that I had given you, but compare this reactivity series with I'll show you another reactivity series. One second. Can you see this reactivity series? Can you see the series?
Yes, sir.
So there'll be few metals which will be missing in this. Can you see this? Is it?
Yes,
visible?
aluminium is missing.
Yeah. So here, if you see, even carbon and hydrogen is missing. Can you see that?
Yes, sir.
So all kind of reactivity series are missing. In few of the series, few elements might be missing. So that is not an issue. But what we should understand is the concept behind the reactivity series. Any doubt till here?
No doubt, sir.
What we understand is, what we understand is that the elements which are on the top, they are the most reactive, and the elements which are below are least reactive. Are we clear till here?
Yes, sir.
So one of the good ways of remembering this reactivity series is that when we look at the YouTube videos, we find how vigorously sodium reacts with cold water. We have seen those videos.
Yes, sir.
So one way of remembering this is that the sodium side is very reactive, and another way is, if you look at these metals are basically useful for making jewelry. Mr. Satya, any doubt?
No doubt, sir.
Now, why they are useful in making jewelry? Two reasons. One is that they are rare. The second is that they are very unreactive. Any doubt?
No doubt, sir.
See, among these three, silver still reacts. So that is why if you see, one second, yeah, Satya, one second.
Okay.
So one thing about silver jewelry, if you ask your mother, one thing about silver jewelry is that silver jewelry usually gets blackened. Have you understood what I've said?
Yes, sir.
You can ask your mom; she will tell you more about this. Because among these three, silver is still reactive. It reacts with the gases present in atmosphere, turns it into black color.
Yes, I've seen it.
Have you seen it?
Yes.
Mr. CB, do you know the name of the compound which gets formed? Mr. Sibang,
Yes, sir.
do you know the name of the compound which gets formed? The black compound which gets formed? Mr. CB is busy in World War.
Sir, it doesn't react because it's least reactive. It doesn't react.
Sibang, you need to listen to the lecture carefully. Mr. Satya, what are we discussing?
So, we are discussing like silver is like reactive and all. So, like you asked
To form?
a compound, like which compound is it?
Yeah. What is the color of the compound?
Black.
Black. Mr. Sibang, have you understood the problem?
So will it be oxygen?
So that is what I am asking you. That is what you need to find. Yeah. So what we are discussing till this time is that in reactivity series, the people who are sitting here are more reactive, and the people who are sitting here, they are least reactive. Satya, any doubt till here?
No doubt, sir.
Okay. Satya, there are 2-3 things that we need to understand more. One is the critical questions which will be asked is about carbon and hydrogen. You will see those questions, but just remember that carbon sits here and hydrogen sits here. Any doubt till here, Satya?
Okay, sir, why is it red?
I'm sorry?
Why is it in red color?
Why is it in red color? Because, see, there will be questions asked. I'll show you the questions which are asked, and that is why this will become bit important. So, for example, this question which is being asked, reaction of metal oxide with carbon. Now, this question, to answer this question, what you need to understand is where carbon is sitting. So, for example, what I'm trying to tell you is that there is a metal oxide like aluminium oxide. There is another metal oxide, say Fe2O3. Their reaction with carbon will differ. Satya, any doubt?
No doubt, sir.
Mr. CB, can you tell us how the reaction will differ? Mr. Sibang,
Yes, sir.
can you tell us how the reaction will differ? Mr. Sibang is interested in World War One. Okay.
Sir, I don't know. I don't know the answer.
Sir, you can think about the answer, no? Mr. Sibang, can you tell us what will happen in these two reactions? Reaction 1 and reaction 2?
In the first reaction won't happen because Zn won't displace MgCO3. But in the second reaction,
Why?
because zinc is less reactive than magnesium, so it can't displace magnesium.
Okay. In the
And
second reaction?
in the second reaction, magnesium will displace zinc from zinc carbonate because it is more reactive than zinc.
Mr. Satya, any doubt?
No doubt, sir.
Okay. Mr. CB, can we extend that argument to these two reactions also, Mr. Sibang?
Yes.
Okay.
So in the first reaction won't happen because aluminium is more reactive than carbon, so the reaction won't happen. But in the second reaction, carbon is more reactive than iron, so it will displace iron and ferric oxide.
Mr. Satya, any doubt?
No doubt, sir.
See, Mr. Satya, why we need to understand these reactions is because when we are doing metallurgy, Mr. CB, can you tell us what is metallurgy?
It is the study of minerals and ores.
Okay. Why do we need to study minerals and ores?
Because there are important metals that are extracted from these minerals and ores, and they are used for different applications.
Shabash. We want important metals to be extracted from their ores. Mr. Satya, any doubt?
No doubt, sir.
So, Mr. Satya, what CB is trying to tell you is that, for example, there are places in India. Okay. So there are places in India. So roughly, this is the map of India. Say, map of India. So there are places in India where you will find iron ores. Iron ores. Mr. CB, can you tell few of the places where you will find iron ores?
Mostly they are found in Sundargarh. In India, they are found in Sundargarh or Keonjhar and Mayurbhanj, mostly in Orissa and Jharkhand.
This side of India, Mr. CB, am I correct?
Yes, in that area.
Satya, have you understood what we are discussing?
Yes.
So you will find iron ores here. Usually you will find the iron ore, it will be combined with oxygen, and this is how it will look like. Roughly, this is how it will look like. Satya, have you understood?
Yes, sir.
Similarly, you will find aluminium ores in India. And let us assume that you will find aluminium ores in this region only, and this is how it looks like. Satya, have you understood?
Yes, sir.
Now, from this ore, please try to understand. From this ore, I want to separate. Satya, what do I want to separate? Mr. CB, what do I want to separate?
So from this, we have to separate aluminium.
Satya, is it making sense or not?
Yes, sir.
So from Al2O3, what do you want to separate? What do you want? Aluminium. From this, you want iron. Mr. Satya, yes or no?
Yes, sir.
Mr. Satya, why do you want iron and aluminium? Why do you want that?
Sir, because like I don't know what's ores. I don't know.
No,
I think
why do you require iron? What do you think? Why do you require iron? Why do you require aluminium?
so many things are made up of
Many things
that.
are made up of it. Of course,
Yeah.
many things are made up of. Most of the things that you see around you are made up of steel. Iron is a major component in steel. Any doubt?
No doubt.
Mr. CB, name one use of aluminium. Mr. CB.
Aluminium is a lightweight metal and very strong, so it's used in aeroplanes and automobiles.
Aeroplane and automobiles. Mr. CB, Mr. Satya, any doubt?
No doubt, sir.
So this is what we want. We want aluminium out of this. We want iron out of this. Satya, is it making sense or not?
Yes, sir.
Now, Satya, the question is that we want to separate iron from this compound. Second question is I want to separate aluminium out of this compound. Now let us assume I react these with carbon. Would carbon be able to displace aluminium? Would carbon be able to displace iron? How should I decide this, Mr. Satya?
So
Yeah,
by like
have you understood the problem? Have you understood the problem?
sir.
Yeah.
Which is least reactive.
Is it making sense now?
Yes, sir.
So, for example, if I give you a table like this, and now I ask you that would carbon be able to replace aluminium, or would carbon be able to replace iron in this compound, would this table help you to make a decision, Mr. Satya?
Yes.
So what do you think? Will this reaction take place?
No, sir.
It won't. Why? Because aluminium. Why will aluminium get displaced? Because carbon is weaker than aluminium. But here, if you see, carbon is stronger than iron, so it will be able to displace. Is it making sense? It is not making sense. We are confused.
Yes, understood.
Mr. CB.
Yes, sir.
So Satya, have you understood why carbon is being considered in this reactivity series?
Yes, sir.
Okay. Now let us understand why we require hydrogen. Yeah? Okay. Now, HCl is hydrochloric acid. Hydrochloric acid. Mr. Satya, are we aware of this?
No, sir. Yes, sir. Yes.
Now we are aware of this.
Yes, sir.
Now I'll show you two reactions. Let us assume we add copper to HCl. Other example is I add iron to HCl. Mr. Satya, what do you think? Which reaction will take place? Which won't take place?
Sir.
Will the first reaction take place?
No, sir. Copper is weaker than hydrogen.
Copper is weaker. It won't be able to displace hydrogen in HCl. Mr. CB, do you agree?
Yes, sir.
Mr. CB, will the second reaction take place?
It depends. It means that if Fe is more reactive than H, then it will displace. In this case, it is reactive, so new compound form will be FeCl 2 or 3.
So the simple answer is that this reaction will take place. This won't take place. Mr. CB, do we agree?
Yes.
See, that is why the reactivity series is important. And that is why you see copper here and hydrogen here. Satya, now is it making sense?
Yes, sir.
Let us take few more examples. Pt plus HCl. Let us take Zn plus HCl. Zn, let us now take Na plus HCl. Yeah, Satya, what do you think? Will this reaction take place?
No, sir. PT is like less reactive.
Okay. Mr. CPU, this reaction won't take place. Why this fact is important?
Because platinum is less reactive than H, hydrogen, and HCl.
Sir, why this fact is important? Why this fact is important?
Because it will tell you whether the reaction will take place or not.
This tells us that if you have pure platinum jewelry, it is unaffected by acid. Is it making sense now?
Oh, yes, yes.
So that is why when you see jewelry, platinum, silver jewelry, even acid is not able to react with these. Satya, is it making sense?
Yes, sir.
Yeah. Okay. Satya, what do you think will happen here?
Yes, sir. It will happen. Zinc is more reactive.
Okay. Mr. CP, what will happen here?
So in this case, zinc is more reactive than hydrogen and HCl, so it will displace H to form a new compound.
Sir, I am asking about the third reaction.
The third reaction is the same. Na is much more reactive than H, so it will displace H and form a new reaction. It's the same case in both second and third equation.
Mr. CP, do you want to do this reaction in the laboratory?
Absolutely not, because Na it's extremely reactive, so the reaction will most probably be explosive.
Mr. Satya, is it making sense?
Yes, sir.
See, Satya, what we have seen in the the YouTube videos that we watched last time was that sodium reacts vigorously with the water. Now, if in the laboratory you take sodium and react it with HCl, do you see the consequences?
Yes, sir.
Now, is the reactivity series making sense?
Yes, sir. सर आज sent you one pic, like सर ने बोला था कि ये सब आएगा एग्जाम.
हाँ ठीक है, वो सब तो कर ही लेंगे, उसकी चिंता मत कीजिए. Because this reactivity series would be important from class 8 to class 12, so that is why we are discussing this in detail. Mr. Satya, any doubt till here?
No, sir.
Mr. PD, any doubt till here?
No, sir.
So when we look at reactivity series, if we know reactivity series, these are the kind of things, these are the kind of conclusions that we are able to easily understand. Mr. Satya. Mr. Satya.
Yes, sir.
So do we see the use of reactivity series now?
Yes, sir.
So usually in books they will write reactions of these metals with cold water. They will write the reactions with steam. They will ask you the reaction with acid, dilute acid. So these are the kind of this table is usually the kind of questions that they will ask with dilute acid, with water, ease of extraction. These are the kind of questions which are asked. Satya, are we clear till here?
Yes, sir.
And using reactivity series, once we know reactivity series, we are able to reach conclusions. So, for example, when we look at this chart, now in this chart, can you see the PDF?
Yes, sir.
We are seeing the reaction of metals with water. Now, when we look at the reactions with water, we are able to see the difference in reactions that various metals have when they react with the water. For example, very violent, less violent, very slow with cold water, but vigorous with steam. Satya, can you see?
Yes, sir.
And then zinc, quite slow with steam, no reaction. And here they don't react with water at all. So any doubt clear?
No doubt, sir.
And then we can see the reaction of metals with HCl. And this is what we see. This is what we have discussed. Vigorous, quite slow, only if acid is concentrated, no reaction even if it is concentrated. Can you see the reducing reactivity of metals with acid? Mr. Satya.
Yes, sir.
Now here they will ask you questions like your sir has said. So for example, Mg plus HCl. Now Mg plus HCl. So your sir might ask, will this reaction take place? Or he might ask, gold plus HCl. Which of these reactions will take place, Mr. Satya? Or copper plus HCl?
So
Yeah, Mr.
the
Satya.
first one.
First will take place. Will the
No,
second
sir.
take place? Mr. Satya?
No, sir.
No, sir. No, sir. Why? And that is why I told you to cram this particular reactivity series, because in this reactivity series you will have both hydrogen as well as carbon. Satya, have you understood?
Yes, sir.
So whenever they ask you a question regarding HCl, all the metals which are above H will react with HCl. All the metals which are below HCl, below H won't react with HCl. Satya, yes or no?
Yes, sir.
If they ask you any question regarding carbon, if there is a oxide which belongs to metal above it, and if there is a oxide which is from any metal below, so which reaction will take place, Mr. Satya? Mr. CB?
So in this case, the first reaction, the second reaction will take place, and the third reaction. The fourth reaction won't take place.
All these reactions will take place,
Yes.
and this won't take place.
Yes.
Mr. Satya, what do you think?
So the first one will take place.
Why the first one will take place, Mr. Satya?
Also because potassium is more reactive than carbon.
Yeah, potassium is more reactive than carbon. Do you think carbon will be able to replace potassium? Do you think?
No, sir. Oh, okay, sir. No.
Is it making sense?
Yes.
Do you think carbon will be able to replace calcium in this compound? Mr. Sivan?
No.
Mr. Satya, what do you think? Will carbon be able to replace magnesium in this compound?
No, sir.
No, sir. Do you think this reaction will take place?
Yes, sir.
Yes, sir. Of course it will take place. Have we understood why do we require carbon and hydrogen in the reactivity series?
Yes, sir.
भाई सीरीज समझ आ रहा है नहीं आ रहा?
I am understanding.
बेटा यही देख रहे हो, कुछ और रात में आप खुला हुआ है साथ में. Okay, so this is what we are discussing. Satya, can you see the screen?
Yes, sir.
Now, say for example, this is what I was telling you guys, that if you take magnesium oxide and mix it with carbon, no reaction will take place. But then you take oxide of lead and then you add carbon, of course reaction will take place. Mr. Satya, doubt still?
No doubt, sir.
Now let us look at this reaction. Mr. Sivan, can you explain us this reaction? Why this reaction has taken place? Mr. CB?
Because iron is more reactive than copper, so it will replace copper in copper oxide and become iron oxide or ferrous oxide.
Satya, have you understood?
Yes, sir.
See, again and again we'll have to refer to this reactivity series. You see copper here, you see iron here. Can you see? So, of course, if you take a oxide of copper and you react it with iron, of course iron will be able to displace. So, some iron oxide plus copper, some oxide of carbon, is some oxide of copper plus iron. Mr. CB, which reaction will take place?
The first reaction won't take place, but the second reaction will take place.
Satya, is it making sense?
Yes, sir.
Satya, do we remember that logic of that? So, In the park, Mr. Satya is sitting with his girlfriend, and then Mr. Ritik Roshan comes. So, Mr. Satya, do you think your girlfriend will keep sitting with you, Mr. Satya?
No, sir.
No, sir. She'll jump and run to meet Mr. Ritik Roshan. But now let us take this example that Mr. Ritik Roshan's girlfriend, Mr. Ritik Roshan's girlfriend is sitting with him, and Mr. Satya comes. Mr. Satya comes. Satya, do you think his girlfriend will run to meet you?
No, sir.
No, sir. This won't happen. And that is the logic of reactivity series. Satya, is it making sense?
Yes, sir.
Okay. Now this is what we had done last time. Competing ions. So for example, we look at this iron plus copper sulfate. Iron sulfate and copper. Mr. CB, which reaction will take place?
The first reaction will take place, but the second reaction won't take place.
Mr. Satya, why won't the second reaction take place?
So because
Yeah.
so copper is less reactive.
Shabash. Copper is less reactive than iron. So copper won't be able to displace iron. Any doubt?
No, sir.
Okay, let us take few more examples. Let us take zinc sulfate. Let us take copper sulfate. Let us take magnesium sulfate. Let us take calcium sulfate. Yeah. Satya, which reaction will take place? Which reaction won't take place? Satya?
So the first one will take place because magnesium is
Why first one will take place?
so because magnesium is more reactive.
Magnesium is more reactive. We see magnesium here. We see zinc here. So this reaction will take place. Nice. Second reaction.
So second will also take because iron is more reactive than copper.
Shabash. Then next.
So this will also take place because potassium is more reactive.
Okay. Fourth reaction.
So this is fourth one is Ca or Cu.
Ca.
So it won't take because calcium is more reactive.
Mr. CB, is it making sense?
Yes, sir.
Mr. CB, will this reaction take place?
Yes, this will take place.
Why this will take place?
Because zinc is more reactive than lead, so it will displace lead in lead chloride.
Will this second reaction take place?
Yes.
Satya, is it making sense?
Yes, sir.
So Satya, do we realize the importance of reactivity series now?
Yes, sir.
Do we understand why is it important?
Yes, sir.
Yeah. So this is what I was trying to tell you that for us the two critical elements are carbon and hydrogen, because when we look at these carbon and hydrogen, then we are able to make a lot of sense, especially regarding metallurgy and the reactions with HCl. So Satya, whenever you go to Europe, you will see these beautiful churches with green tops. Can you see this photograph?
Yes, sir.
So these green tops, they are compounds of copper. Do you have any copper utensil at your home, Mr. Satya?
Yes, sir. Not sure, like I guess.
I think you would have a glass or something. You would have a glass. Usually nowadays you will have either a glass or a jar of copper. Just ask your mother. She will tell you that usually the copper again reacts with the gases in atmosphere to form a green compound of copper. Mr. CB, do we know the name of this compound? Satya, have you understood?
Yes, sir.
So usually you'll have to clean this.
Copper carbonate.
You'll have to clean this copper vessel so that this green color goes away. Satya, is it making sense or not?
Yes, sir.
Just ask your mom, she'll tell you. Usually nowadays people have containers of copper in their home. It is good. It has medicinal properties. Okay, are we clear till here?
Yes, sir.
Okay. And now there is this use of reactivity series. See, one of the use is this reaction. This is called thermite reaction. This is very vigorous reaction and generates a lot of heat. It is usually used for welding. Satya, is it making sense? This, Satya, you won't be able to understand. But again, one of the importance is to protect iron wherever you have to protect iron. Again, these are something that you will be doing, Satya, in class 9th. Satya, are we clear till here?
Yes, sir.
Okay. So let us try to look at this. Satya, any doubt till here? We'll do one or two questions from this sheet. I think you will be able to understand. And okay, before we start doing the questions, Satya, are you comfortable with this now? Have you understood? What does this mean?
Yes, sir.
So basically, Satya, what this means is that, see, vigorous reaction with cold water, slow reaction. Now, once you start going down, you'll first see vigorous, then you see slow, then you see reaction with steam, and then you see nothing at all. Satya, have you understood?
Yes, sir.
Again, when you see the reactions of dilute with the dilute acids, again, as you start going down from vigorous violent reactions to no reaction, is it making sense?
Yes, sir.
Again for oxygen, again for oxygen. So from bright heat to no reaction, is it making sense?
Yes, sir.
Can you see the behavior?
Yes, sir.
Is it looking logical now?
Yes, sir.
So we'll do one or two questions to understand uh, how this makes sense. The application of reactivity series. First, try to do this question of your own, and then we'll discuss. Yeah, Satya,
Okay, sir.
Mr. CB. So, Mr. Satya, let us try to understand this question. Three metals X, Y, Z were reacted with water. Oxides of the same three metals, that is, oxide of X, oxide of Y, oxide of Z, were also heated strongly with carbon. Satya, have we understood till here?
Yes, sir.
Okay. Now let us try to understand reaction of the metal with water. Yeah. So vigorous reaction with cold water, no reaction observed with cold water, but reaction observed with steam. Satya, have you understood this?
Yes, sir.
Satya, do you agree that in the reactivity series, if this is carbon, this is hydrogen, or let us not add carbon and hydrogen now. Okay. Tell me something, Satya. Do you agree? This no reaction, if we have to place XYZ in the reactivity series, this vigorous cold water, no reaction, cold water with steam, this vigorous cold water would be X, no reaction would be Y, no reaction with cold water but reaction with steam. This is how it will look like. Satya, do we agree?
Yes, sir.
Mr. CB, do we agree?
Yes, sir.
So what I'm suggesting is that if we look at this data only, this is what we are able to agree. Do we? Is there any confusion till here?
No, sir.
Okay. Now let us look at this data. Now let us look at the other data which is given to us. This one. Reaction of metal oxide with carbon. Oxide of this metal with carbon. See, if there is an oxide of X, it doesn't react, the carbon doesn't react with this at all. This means that X would be above carbon. Do we agree to this?
Yes, sir.
Again for Z, if we see that there is no reaction, again do we agree that Z would be above carbon? Mr. CB.
Yes, sir.
And the third reaction is metal and carbon dioxide is produced. That means that Y would be below carbon. Do we agree to this?
Yes, sir.
Yes, sir. No, sir. Mr. Satya.
No, sir. I didn't understand.
Which point you didn't understand?
So now you told that one. That.
The last point. Y.
Yeah.
Okay. See, Satya, I'm taking an oxide of Y. That means, let us say that the oxide of Y looks something like this. I reacted with carbon. Now, if you see, metal and carbon dioxide is produced, which means if carbon dioxide is produced, this means that carbon is able to replace this Y. Satya, is it making sense?
Yes, sir.
Therefore, Y would be less reactive than carbon. Do we agree to this?
Yes, sir.
And that is why Y will come below in the activity series. Is it making sense now?
Yes, sir.
Mr. CB, is it making sense?
Yes, sir.
Now look, Satya, any confusion till here?
No, sir.
See, this is one of the difficult questions, so don't worry, but I want you to understand the logic. This kind of question won't come in your exam, Satya. So don't worry, I'm just trying to tell you how the logic works like. Yeah. Now, we want the correct conclusion. X is sodium and Y is magnesium. Mr. CB, is it correct?
Yes, sir.
Mr. CB, is it correct?
Yes, sir.
Can Y be magnesium?
No.
So is it correct?
No, no.
Mr. CB, is B correct?
No, X is not the least reactive.
Z is less reactive than Y.
No, this is false.
Z is magnesium and Y is copper. Does it make sense?
Yes, this makes sense.
This makes sense. Satya, have you understood the logic?
Yes, sir.
Satya, don't worry, these kind of questions won't come. They are actually class 10th questions. But I want you to understand the logic, how the reactivity series works like.
Yes, sir.
Have you got a bit of understanding of reactivity series?
Yes, sir.
Okay, let us do one more question. Don't worry if you are not able to do this question, but at least try to apply logic. Yeah? Try to do this question. So, Mr. Satya, let's look at this question now. A student is given a metal Z and its oxide. Yeah? The student does some experiments to find out the position of metal Z in the reactivity series. Metal Z reacted slowly with dilute acid. Satya, have you understood this?
Yes, sir.
Metal Z reacted slowly with steam but not with water. Have you understood this?
Yes, sir.
Okay. The oxide of metal Z reacted when heated with carbon. So in reactivity series, this is where carbon is. Mr. Satya, do we agree?
Yes, sir.
Okay. So Mr. Satya, metal Z reacts slowly with dilute HCl. Because it is reacting slowly, do you think it will be top or it will be a bit below? Satya.
Sir, bit below.
Yeah. Metal Z reacted slowly with steam but not with water. Again, what is your conclusion?
Sir, down.
Down only.
Yeah.
Oxide of metal Z reacted when heated with carbon. Would it be? Sorry.
Sir, I think it would be up.
Okay. Oxide of metal Z reacted when heated with carbon. Mr. CB, do you think Z will be here or Z will be here?
If it is reacting with carbon, then it is lower than carbon.
Satya, is it making sense?
Yes.
So, Mr. Satya, do you think it is between calcium and sodium? Satya?
No, sir. It's below.
Is it between magnesium and calcium? Mr. Satya?
Also, no.
No. So these two choices are anyways out. Now we are just left with is between copper and hydrogen or it is between hydrogen and iron. Mr. CB, what do you think?
So this would be between copper and hydrogen because we can see in the first statement that metal Z reacts slowly with dilute hydrochloric acid. So that means it is more reactive than hydrogen.
Mr. CB, if it reacts with dilute HCl, it can't be below HCl.
Yes, it can't be below HCl.
So is it making sense?
Yes, sir.
So even this choice is out. Satya, yes or no?
Yes, sir.
So the only choice that we have is it is between hydrogen and iron. Yes sir, no sir.
Yes, sir.